Hello, people. I think I'm live. Alright, so this is this guy again, Mariusz. I'll be going through some of the web challenges that people found difficult in the CTF that we held on Saturday. So if you somehow were living under a rock and you didn't hear that the Monash Cybersecurity Club, MonSec, was running a beginner capture the flag or CTF competition this Saturday, it was from 9 till 5. Plenty of teams competed, and in case you're wondering about the scoreboard, ooh, that's not the right scoreboard. This is the right scoreboard. This is how it looked at the end. The challenges are still up, so if you want to participate, simply go to game.monsec.io. Now, as promised, I will be going over some challenges which people found hard. So it becomes very obvious very quickly. Let me just make things real nice and big. Okay, that's not a good idea. That people had a lot of struggles on VWeeb O blog comment. So let's go to O blog comment, and we see the hint that it takes time. And because it takes time, I will probably do this challenge like sort of first, and then I will leave it alone in the background while it's getting solved, and then do another challenge. So try and keep up. Now, this is an SQL injection challenge. The best way to figure that out is by seeing, well, it's before all these other challenges which are SQL injection challenges, and there's also some SQL injection challenges afterwards as well, so it all lines up. Okay, so blog comment. Now this is not your usual SQL injection. You think, oh, okay, we can do 1 equals 1, limit 1 or something, or even any union stuff, or even any Boolean stuff. So this is a time-based SQL injection here. That's why the hint says it takes time. So in order to not go insane, I'm going to just use a tool called SQL Map to do all the SQL injecting for me. So SQL Map is great. Please install it and use it for hacking things that you are allowed to hack, such as the MonSec CTF VWeeb. So because I'm such a fan of SQL Map, I have somehow memorized the parameters that we need. So batch tells it to just accept the default for everything because I can't be bothered hitting enter myself. Forms will actually find this, if we inspect the element, form will find this comment field and the submit button and see that it's a post form and automatically make the correct request. So it means we don't have to actually figure out what the form is, so we can be even lazier. And then finally the actual URL, which is this. Cool. And now maybe this might even work. So it tries a bunch of SQL injections unsuccessfully, and then it gets stuck on the one that we want, the time-based blind. So the way that time-based SQL injection works is, since every time we make a request, we actually can't observe any differences in the outputs. So sometimes you can see like a true or a false page, like, hey, we found this user, or we didn't find this user. The thing with this challenge is it always gives you the exact same response every time. So the way we can work around that with an SQL injection would be to make it execute a sleep command so that we can actually observe a difference in output. So usually we would get like a result in under a second, but if the sleep command runs, then we're going to wait a whopping 5 seconds. So we can observe the difference then. And after we do that, and we found the SQL injection, so now we need to actually exploit it. So the way I like to do that is to do, okay, let's dump something and let's dump the table called users. So you can use the option tables to get a list of tables. But that's going to take so long with a time-based injection. So, and a good guess is the table users, so I'm just going to do that. And then it tells us, hey, I'm going to like build some statistical models. I don't even know why it needs some fancy statistical models. Maybe there's something very efficient. Who knows? But then thanks to all of our options, including batch, everything is just going to run by itself now. So it found out that the database is called O, which lines up with the challenge. It found that there are 3 columns, which is nice. And now it's finding what each of the columns are called. So we don't even need to worry about guessing the columns. SQL Map literally gets all the information that we could ever possibly need. Now make sure to stay tuned even if you are not interested in the web challenges, because we're going to have some other team members going through some of the other more difficult challenges, including binary and cryptography. So stay tuned for that, and make sure to ask questions either on the Twitch chat or on the Discord, which the team is monitoring. So as you can see, time-based SQL injection takes a lot of time because it's going to execute this. It's going to wait for 5 seconds for at least once every character. So it's going to take quite a while, but it should be done in a few minutes. So since it now extracted the number of columns, what the columns are called, and the number of entries, so the rows, now it can actually start extracting the data itself. So I'll just let that run in the background while we work on another challenge. Another challenge which few people solved, in fact only one team solved, would be X marks the spot. Now the first thing you're going to realize is, this is not a clicky link. What can I do? Well, if you click on anything else, you're going to see that the URL scheme lines up with the letters. So challenge U is at the URL with U, and V is at URL V, W, W, and so on. So we can guess, hey, maybe X is at X. And indeed it is. We have the message X marks the spot. But then we don't know where to go. If you don't know where to go and you're on a website, then you need to brute force some of the directories. Now I'm just going to switch over to my Kali, because I can't be bothered installing dirbuster on my actual system. So dirbuster busts directories. So it finds what exists on a web server and what doesn't. So if you do not have a list of possible URLs or like paths as part of the website, then you're going to probably need to do something like dirbuster to just brute force the possible directory and file names. Now I'll browse to the to some word list. So these come installed with dirbuster. You just need to find them. It's on Kali, it's under user share dirbuster word lists. So quite a mouthful there. And then I'm going to uncheck be recursive because we're going to do things a bit manually because it's going to be faster for our case. So as soon as we run it for a few seconds, it's doing a lot of requests per second. We can already stop it because I can see it found a file, which is actually a directory, support. So how does it know that support exists? Well, it just observes how the server responds. So if we go to like blah and slash, it's going to say 404 not found. Let me try and make it this bigger as well. Yeah, 404 not found. Now, if we do support, then it's going to tell us 403 forbidden. That means there's no index file there, and the server by default is going to say, hey, you can't access this because there's like, it does exist, but I can't give it to you. So it just says forbidden. And Dobuster observes that and notes that as an existing thing. Now I'm going to say, okay, now that we know that support exists, let's debust into support. Yep, so it's busting the directories. Okay, yeah, it's doing everything. Cool. This one's going to take probably a little longer. Let's have a look at how challenge O is going. Okay, almost there. Okay, so there's people asking, hey, how do I know how to use SQL Map? And that is an excellent question because, believe it or not, not everyone is born with the knowledge of flags to pass to SQL Map. My favorite resource is looking up SQL Map docs. So docs is short for documentation. It's actually going to find you the SQL Map wiki on GitHub. And that's all of the parameters that you can pass to it. Probably not the best for like learning how to use it, but if you want a specific option, this is how you can do it. SQL Map also, let me just open another SQL Map. Right, if you go SQL Map -H, most command line programs, including SQL Map, you can do -H to get help. And this gives you a much lower set of options, the most important ones, basically. If you actually want to learn how to use SQL Map, like in reality without reading the entire, basically textbook, then the way you do that is by using it. So first you Google some tutorials or you watch me using it, to get an idea of some of the flags. If you don't understand them, then you look them up in the manual or the help page. And as you continue playing around with things, you gain experience and then you figure out how to use them. There's no one magic way to learn things. It's mostly experience. Okay, right, so I think we have solved plenty of things at the moment. So SQL Map is showing partial results, so it hasn't finished dumping the entire table, but it found this, which looks like a hash for the user not admin. So I just copy that, and if we Google for it, we don't get anything. But if we look up some hash cracking website and pick anyone really, and say, okay, I'm not a robot, and then I need to solve this live, yes. Alright, too easy this time. And then we get the result. So this is actually what you would need to submit for the CTF in order to get the points for the flag. Because this is the password of the not admin user. So that's challenge O. And if we just cancel this prematurely, then it's going to give us a nice table of the results it got so far. Cool. Am I looking for time? Okay, so LDuck and then some numbers and stuff asks, when I navigate to X without a slash at the end, I get redirected to web/x/. So this is an unfortunate side effect of the server not being set up ideally. You should be able to go to X with a slash at the end correctly. What the server is trying to do, if you just do X without a slash, is it's saying, hey, the X directory exists, so I'll just slap a slash onto the end. Unfortunately, the server itself doesn't know that it's called weeb.game.monsec.io, and it's unfortunately redirecting to web instead, because that's what it happens to be called on the back end. So sorry about that. It's a bit of a glitch basically on the back end. Okay, so now our Buster for challenge X. It looks pretty good. So we found x/support/phpMyAdmin. Okay, that sounds extremely promising. And then we get an admin login page. And now this login page is not vulnerable to SQL injection. You need to brute force it. So I would suggest a tool such as Hydra. Doing this live on stream is going to take a little bit too long, and I may or may not have forgotten how to use Hydra. So please do that in your own time, but I assure you that this works. And you can get the flag by logging in with the correct username and password. Cool. How are you going for time? Okay, so it's been about 17 minutes. We have plenty of time. Rightio, let me just check if there's any questions. Okay, I think I have resolved all the questions on the Twitch. And there are no questions on the Discord. But please ask questions live on the Twitch chat or the Discord, so I can answer them live, right? Nothing better than getting a question answered almost immediately. Let's have a look at the administrator panel. Some other challenges. So I went over O, went over X, and now we have, okay, U, declare the document. I'm quite surprised that only one team solved it, because it was not too difficult of a challenge. The dead giveaway is that this deals with XML. So if we submit this pre-filled XML document, we get hello world. If we change hello world to like some other message, we get that other message. Cool. Now note that author is not actually like used, so it's not that interesting for our purposes. We are also told that flag is here, except we can't access it because you are not me. So what that's trying to allude to is that you need to persuade the server to request this flag on your behalf and then send it back to you, so that it looks like the server is asking itself for the flag. If you look up XML attacks, you're going to find stuff about XXE. And if you do a little bit of research about XXE attacks, you'll see some very good proof of concept examples such as this one, which I'm just going to directly copy paste into here. Now, if you just use this as is, it's not going to be very useful because it's not in the format that vweeb expects. Because see, we have the document tag and then the author tag inside that and body tag inside document. Well, here we have like stock check and product ID. So if we just get rid of this, then we just get nothing, all right? And if we change this to document and this to body, and this to document to make sure it's correctly formatted. Spacing doesn't matter, XML doesn't really care. And then we click submit. Ooh, suddenly we get this tasty information, which we actually don't care about. This is, in fact, the contents of etc/password, which is on Unix systems where the list of all users, their groups, their login shells, and a little bit of other metadata is stored. Now, in this case, we want the flag. So how do we do that? Well, we know the flag is here. So maybe we can try requesting this instead of the file. We request some remote document like the flag, right? And they're told, hey, not me. So the reason this happens, some networking stuff, but a way to solve it would be to instead say, hey, ask localhost. So in other words, I'm going to make a HTTP myself. Then we get a lot of errors, but those errors now errors are often not shown on most websites because it is considered a secure, like, hey, there's an error on line 6 of the source code. That's quite a serious security issue. However, that doesn't prevent XXE from working, but in this particular example, it would. Great. So I'm being told that there's legs, so I don't. I'll try to tighten my internet usage a bit more. Maybe that's going to make things better. Let's keep going. Any questions on the Discord? No questions on the Discord either. So let us continue. Q, best buddies. Now, also only has a single solve, but in this case, I'm not too disappointed because it is a bit of a funky challenge. Let me just clear the cookies. Okay. So we have some web application where there's like a buddy ID and we're told, okay, their username is Alice. If we go to the edit page, then we can say, okay, what about if we go buddy ID is 2? And then we go back to this page and we observe, okay, the ID has updated and the buddy's username is not admin42. However, in terms of things that we see on the client side, we only see the PHP session ID, which means the server is taking care of this ID for us. We don't actually send the server the ID, except when we set it here, the server keeps track of that for us using this session ID. But we can control it to some extent. So let's just try a quick SQL injection and be told by the browser, nope, you must send a number. So I'm just going to, there's a whole bunch of ways to get around this, but I'm just going to use Firefox's edit and resend tool. And we sent some SQL injection. And then we get an error, so that means our SQL injection is working. Now, this is a bit annoying to do ourselves, so once again, I will hand over to my trusty friend, SQL Map. So again, we want batch, But for this particular scenario, there's a bit of a glitch with SQL Map if you use forms, because it expects some sort of positive result. And if you make it auto-generate the form, it's going to try a non-numeric ID, while a positive result requires a numeric ID. So that's a bit of an annoying thing to worry about. But we can do, okay, so it's at URL Q and then edit.php. That's what we're trying to attack. However, the results need to be observed somewhere else. And that's done with the second URL parameter, which is going to be basically this, except index.php, or we don't even need anything because of how the server resolves it. Cool, cool. So we're giving it the second URL. Is there anything else I need? Yes, there is. Because if I just send it right now, then it says, well, I don't know what you want me to inject into because I didn't specify -- forms. Instead of -- forms, I'm going to say, okay, the data that you actually want to send looks like this. There's a parameter, body, and submit, and this is made with a post request. So that's why I'm going to do -- data. That's for a post request. If it's a get request, then you just put it with like a question mark and like something equals something else format. That's how it is. But instead we're going to do it in -- data because it's a post request. So we're going to say body equals 1 because that's going to give us Alice, which is like a positive result. So it's easier for SQL Map to think about. And we're going to say submit equals submit because that's what we usually send. Nice, nice. Now maybe it'll even work. Let's have a look. And almost immediately we are told that it might be vulnerable to cross-site scripting attacks. That's for attacking clients of websites rather than websites themselves. So in this particular case, we don't care. If you did the lacrosse site scripting challenges, you would care a lot about XSS. But in this case, we find that there is a Boolean-based blind injection. It also finds some other injections. And very conveniently, it finds a union query injection actually as well, which is going to make the extraction process a lot easier. So if we say, hey, let's dump the table of users, then it's going to get it all in like one shot, like that, very quick, not one character at a time. And then it's going to attempt to crack those passwords, and congratulations, it actually finds what the corresponding password for not admin is. It happens to be Leslie, which is what you would submit. Let me see if there's any questions. There doesn't appear to be anything in the Twitch chat or on the Discord. So what did we cover today? We covered VWeeb-O, which was a time-based SQL injection, X, which was brute forcing directories and then credentials, U, declared a document, which was XXE, and Q, which was second order SQL injection, which basically just means the results are on a different page than where you send things. So I am told, oh, no such option second URL. That's a good question. Never mind, I had a typo. Okay, that's a good answer. I believe SQL Map had renamed that parameter at one point or another. So what we had second URL. So the second rec. Oh yeah, there was a second order option, but I think it's deprecated now. So you shouldn't be using it. You should be using second URL. But yeah, that's how it works. Learn SQL Map because it's awesome for doing SQL injections. It could make your life, it makes your life a lot easier for what? M, N, O, P, and Q. It's probably going to make your life harder for L. And for R, I wonder if you can use it for R, but we'll see, we'll see. No such options. Cool. No questions on the Discord. So I shall move on to the binary category of challenges, where there was Search Engine by Daniel, which was solved by 0 people, which is not very good. But Daniel will be covering that. In the meantime, I will cover. Where is it? Deadrop, solved by one team. Could you go over L? Alright, L duck, I will go over L. What is it? Login form. Okay, so this is sort of a textbook SQL injection, but you also need to use limit. If you try to use SQL map on this, it's going to make things harder, but you will solve it as well. So if we try 1 or 1 equals 1 something, then it's going to say invalid credentials because it returns more than one row. Since the condition 1 equals 1 is true for every single row in the database, it's going to return more than one row, which is not what usually happens when you're logging into a website. You only log into a single user at a time. So if you do limit 1, then that's going to get you past that. Let's try throwing this at SQL Map. So I'm going to do batch, I'm going to do forms because I'm lazy, and I'm going to give it this. Really? So it does a lot of funky stuff. It finds time-based blind, which is a bit bad because it's going to take ages. So I would not recommend using SQL Map for this particular challenge because it is so trivial. It's possible, yeah, so let's not use time-based blind. It's possible, but it's going to take a lot longer, so I'm not going to do this on stream. If you do level 5 and risk-free, so that SQL Map attempts a much wider range of SQL injections, it's possible that it'll find some other blind attack which might be able to extract you the password, so then you can log in validly through the form. Awesome. Now let's do Deadrop. If you have never done binary exploitation, you might want to close your eyes because it'll be a bit funky what I'm going to be doing. But this challenge isn't too complicated. It just requires a single chain of return-oriented programming. If you know what that means, great. If you don't, maybe I can teach you. So, if you download the Deadrop binary and then run it on your Linux machine, let me just make things a bit bigger. Then we get a question, what is the answer? And then it tells us by. if we do something very long, then it does a segmentation fault. If we go to the challenge, it's going to tell you that Deadrop also has this server exposed. So if we go and try to connect to this server using this command where nc is netcat, then it's going to do the exact same thing. Welcome, what is the answer? And then bye, right? The goal is that you exploit this remote server so that you can get the information that only the server holds. Now, how can we do that? Well, since there's a segmentation fault, that means there's something going wrong with our input, that it's being treated as something that it should not be. Now, to make things easier to play around with, I also made this file profile.rr2 for Radare, which is my debugger of choice. And it looks like this. It basically just says, okay, when I'm debugging this program, I want to use run2 to redirect it so that it listens on port 999. That's just how I like to do it. Oh no, now this froze. That's cool. How can Vim freeze? Ah, so sad. Okay. Okay. Profile.rr2 so that we can tell Radare to use this as a debug profile and debug Deadrop as we're running it. And then you see that it freezes because it means that it's actually waiting for this connection on port 999. And then it continues along. Awesome. If you don't want to use Radare, that's fine. You can use GDB or any other sort of binary analysis utilities. Now I'm going to analyze, as I like to say, or like analyze all or something, however they use it, and then function list. There is a function called main, which is where the program actually starts, and there seems to be a function called win. So that sounds very promising. If we go to main and visualize it, we're going to see that it calls a function ask question. If we go to it by clicking by hitting 1 on the keyboard, then we see that this code executes, including an fgets call, which is what actually takes our input. Now let's quit, so QQ, and then seek to the win function. If we look there, then we see that as part of it, let me try and, yeah, that's not a good sign. Okay, that if we try to go, if we go to the win function, then it's going to, this is very annoying. Oh, there we go. So it's going to load this string catflag.txt and it's going to put it into the system function, which is exactly what we want because it's going to run, it's basically going to run this command in the shell, which is plenty enough to get the flag if it actually happens to be stored in flag.txt. Let's actually not do that. Let's connect again. And then I'm going to do a debug breakpoint at ask question because that's where the actual vulnerable code is. And I'm going to continue up to that point. And then let's visualize that and step over it one by one. When we get to the fgets call, it hangs because it's waiting on input. So we do like blah, blah. It jumps to the next line, but then we see that blah, blah is now on the stack. So that's cool. In order to actually see exactly where we're overflowing to, I'm going to use pwn cyclic and do like 100 to get a unique pattern of characters so that it's easier to identify exactly where we're up to. I'm going to immediately send those through. Break on sim.askQuestion, continue to the askQuestion function, and then Shift S to jump over each instruction, and we get this big blob. And then just before we leave, just before we hit the return instruction, we see that this is at the top of the stack, so it's going to try and interpret this as a return value. Now, due to endianness, things are sort of backwards, so actually only care about these 4 bytes here. So 616161 6B. So let me just if we go pwn cyclic and then look up 616161, and then what was it? 6B, it's going to say 40. So that means the offset to the return address is 40. Awesome sauce. So then I'm going to make an exploit file, and I'm going to import pwn tools so that things are easier to hack. I'm going to say that the process that we are hacking exists on localhost and port 999. Then the initial padding that we do is just to get us to the return address. So just anything times 40. And now, well, what do we do? How do we actually call the win function? So conveniently, pwn-tools has an ELF analyzer. ELF are the executable formats on Linux machines, so we can do ELF and then deadrop, I believe. Now to get the address of the win function, I can simply do elf.symbols win. So in terms of what we actually want to send, is we want to send the padding first so that we get to the return address, but then we want to call the win function. So then I'm just going to say, okay, after the padding, then we want to call the win function. And I'm using P64 so that it's padded to 64 bits. Since the program is 64 bits, we need it like this so that the address isn't accidentally cut off. P64 just makes sure to add enough zeros so that it's 64 bits. Then we can do p.sendLine of the payload, and then I'm just going to do interactive so that we can localhost so that we can observe what happens next ourselves. That's looking pretty good to me. So let's run this. And if you have any questions, please ask me on the Discord or the Twitch chat. So there is no file deadrop because I'm in the wrong directory. Okay. What's a CTF deadrop? Cool. All right. So we've initialized the connection and it has done some analysis stuff. But now we can run Radare and let's say, okay, so let's break at ask question and then continue to it and then step over things one by one. So after we call fget, then we're going to have exactly 40 A's, and then after those A's, we're going to have the address of the win function, which happens to be this. Which means that once we reach the ret instruction, then the win function address, as I just showed before, is going to be at the top of the stack. Beautiful. So we return into sim.win, and now we're ready to win. So we jump along. Uh-oh, what happened there? Well, we just jumped over this entire system call. What happened? Well, there was a comparison against OX dead. So, in fact, if I just close this, the first argument, which happens to be stored in the RDI, the RDI register, so let me just do dot to go back to where we are up to. The RDI register is where the first argument always goes on x86 64-bit calling conventions on Linux. You can Google that sort of stuff if you're interested in it. x86 calling conventions. And Wikipedia has a pretty cool article. If we go to 64-bit, then we can see this system V is for Linux, so the first argument is RDI. Very nice. But how do we actually get things into RDI? Well, we're going to need what's called a gadget. So that's just some instruction lying around in the code that we can return to put the desired value into the register. The way I'm going to do that is by using a tool called ropper and analyze the file deadrop, and because there's going to be a lot of output, I'm going to tell it to search for pop RDI. This means that since we are controlling the stack due to our buffer overflow exploit, we can put anything we want in the stack. So if we can do a pop, that means it's going to read something off the stack and shove it into the RDI register, which is what we want. I don't have ropper installed. Beautiful. Let's do this live, shall we? Since I am reckless with virtual machine, I'm going to use sudo pip install, which is not a good idea on most systems. Cool. Okay, let's try again. Beautiful. So we've got pop RDI and then RAT. So that means that we can simply put something into RDI and then it's going to immediately return to the next address. So let's go to our exploit script, and then I'm going to say address of pop RDI is this. And I'm just going to make this a comment because this is the actual address that we care about. So in terms of how our payload is going to look now, it's going to say, okay, we want to actually return to the pop RDI gadget. And then the next value that's going to read off the stack is OX dead, because that's what the function wanted. Then, so let's just comment that and say, basically this line makes it so that RDI equals OX dead. So it's going to go to the gadget, consume this OX dead from the stack, and then that return after the gadget, we're going to return to the win function. So let's have a look if that works. So I'm going to analyze all the things, break at ask question, and then visualize. So jump, 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 jump. And then the stuff gets loaded on the stack, including dead. And then we return to this address, which happens to be pop RDI. Who would have guessed? Well, that's exactly what we wanted. And now the thing at the top of the stack is actually dead. So as soon as we go over this instruction, watch as the RDI register changes and the dead gets consumed off the stack. So next, and dead is gone, and now the next address is over there, and RDI is correctly dead. We skip to the next instruction, and because I told it to go to the win function after that, that's where it is. So then we jump along, and it completes the comparison against dead successfully, so it does not jump over this block of code. And then it actually calls the system function. So if we run this if we just run this straight up without doing any debugging, then we're going to get the message cat flag.txt file not found. That's because I don't actually have a file, a flag.txt file here. But if we update our exploit so that it actually points to the challenge server, so port 610 on chitu.game.monsec.io, and 610, boom. And we have managed to remotely exploit the MonSec game server and read the file flag.txt just through really specially crafting the payload that we sent. First 40 A's so that we get to the return address, then returning so that we can set RDI to dead as we like it, and then go to win where it compares RDI, which is the first argument, against dead. And then, finally, we actually get the flag. Too easy, am I right? Okay. Now, looking at the Twitch comments, and I'll be going soon because the committee is probably very unhappy how much time I'm hogging. Would it be possible to do this with GDB? Probably. I don't know how to use GDB because I find GDB to be hard to use. On the other hand, you might find Radare hard to use. Use whatever you like. As long as you can basically step over each instruction and look at addresses in memory, you're basically golden. Right? That's all you really need to do in terms of debugging a binary. You, sir, is leaked. Thank you very much. That's why I really wanted to go over this challenge, because it makes me look much more leaked than I actually am. Another question. Are these streams recorded? Yes, these streams are recorded. Let me tell you how to find them. If you go to go.monsec.io/live, which happens to be this very stream, you will find the videos section. So this stores the past 2 weeks of our workshops. However, in the long run, you really want to be going to go.monsec.io/YouTube, where you can find all of our workshops recorded, and they're not going to be deleted after 2 weeks because YouTube is not Twitch. So please subscribe to go.monsec.io/YouTube, and you can watch the recordings in your own time and learn stuff, even if you can't make it live. Awesome. Now I'll try to hand over to the committee, to someone else who's going to be presenting. So let's have a look how that goes.
I'll probably switch over to this for now. Actually, what am I doing? Live. There we go. Wonderful. Hello. My name is Daniel. I am going to be going over some of the binary challenges. I want to go over two in particular that weren't really well solved. Mariesh, just before, has already done the Deadrock challenge, which only had one solve. I will be going over Search Engine, which had no solves, and I will also be going over the Boy or Girl, which only had about 3. So, to begin, let's go to, that's the wrong directory, Daniel. Great start, cool. So, if we have a look at the Boy or Girl, doesn't really give you too much, but the first thing I want to point out is with this sort of challenge, something that is always going to be a problem is memory protection. Memory protection was put in place specifically to stop these types of attacks. So if you're going to, when you're wanting to do stuff like this, you're going to want to turn off certain memory protections. A lot of them have been turned off at compile time. So if we check sec, which is a part of Pwn Tools, and we actually look at the challenge, we can see that basically nothing is running. But the only thing, but there is one more type of memory protection that would still be running, which is ASLR. Pretty much just copy and paste this, command, paste it in, enter your details, and any program started from this point onwards won't have memory protection. If you do want to get memory protection back, just change this. I think it's to a 2 or a 1. Google can help you with that one. Cool, so let's get into what this challenge actually is. If we have a look at the binary, we can see that first off, we want to run it. It gives you just, are you a boy or a girl? Say a boy, and it says, it gives you a yes, of course you're a boy. Cool. So if we actually have a look at the main function here, we see that not a whole lot is working, or not a whole lot is going on. The only real interesting thing is that it calls a function called vulnerable. So if we go into vulnerable, again, not a whole lot is happening. You have the gets, which is indicative of a buffer overflow, which you should have got just because the previous 2 challenges were also buffer overflows. Yeah, that doesn't really help all that much. Something that you can do as well is if you go for, I think it's info functions. Yes. Info functions will dump every function in the binary, which there is quite a few debug functions. And this is one of the reasons why Mariesh prefers going to Radare, because it's a lot easier to find user-made functions in Radare, but theoretically in GDB you can go through here to actually find any interesting function there. But skipping through recon on this, the function that we're going to want here is, I believe, just called win. No. No, it's, there we go. Call this function. This function puts something on the stack and then calls system. You could probably guess, seeing how deadrock function, that all this is doing is putting on the string cat flag, right? So we really want to get into this function. How do we do that? Well, following pretty much what happened in deadrock, if we get point cyclic, we run it, and we input that, you see that it crashes at this address. This is actually probably a good time to mention GDB on its own is a terrible program. Don't use it by itself. Install plugins like Jeff here, which gives you this really pretty, colorful output. Probably should have mentioned that earlier. Anyway, so yes, if we put this into point cyclic, we see that the point at which the return address gets overwritten is at this 76. Is at the 77th character, right? So I'm in the wrong one here. If we go here, and we start doing an exploit.py, we do Python 2, and let's just jot down the padding as 76. Cool. Then we print the padding, run that as Python 2. Remember, don't use Python 3 for binary exploitation unless you know the ins and outs of Python 3. Python 2 is a hell of a lot simpler. And we pump that into challenge. Whoops, my mistake. Pump that into challenge. We get an illegal instruction. What is going on here? Okay. One moment. Running that, going into that, challenge sig illegal. Whoops. This is vulnerable. Cool, we're on here. What is happening? At the top of the stack, what's happening here? Oh, right. So Python actually outputs a 0 character afterwards. So if we want it to crash without it working, because Python will always put a character after whatever you print, just to tell it to terminate, we put it as that. There we go. Because that's technically 76. Yeah. Cool. So that's that. Now we've got to the point where we can override the buffer, and then it will have and then it will jump to the one after it, right? So we need to know where to jump to. Well, in GDB, you can use something called x/x to get the hexadecimal value of any particular point. For instance, if we want to see where the stack pointer is at the moment, we can do $ESP, because ESP is the register with the stack pointer. Or what we can do is just do x/x, call this function, and it will give us the hexadecimal address of this function, or of the function, call this function. Right? So if we put that into the exploit here, and remember Indianness, so you always want to do it backwards, but not quite backwards. Whoops. 0, 4, and 8. Just put a preceding 0 there, just for ease of reading, more or less. And we try and run that again. We see that I didn't update the padding. Cool. Did I mess something up again? What? Okay. Always fun doing these things live. Put that into payload. payload run. What is this appearing to do? So the stack address, this is not what it's meant to be doing. Okay, if we go X, we can look at what the stack is actually doing at the moment. 04929100. What if I do that? Is that what's messing it up? Nope. I think I'm a cheat a little bit. 76. Oh, I'm an idiot. Alright. Forgot to actually put the return address into the exploit. You know, tends to help to do that. And there you go. Sorry about that. So basically what is happening here is this part is overriding the buffer, and then this part is the return address where it's going to crop the memory in such a way that it's going to jump to. We found the return address just from doing x+x, call this function, and it was that address there. And then we put it back into the return address here, and it was a bit weird on how it was, just because of Little Indian. Google that if you want. It's actually a reference to Gulliver's Travel. Yeah, just Indianness. Oh, what the hell? Alright, there you go. Yeah. Cool. And then, yeah, you input that, and it puts out the flag. If we want to do this just on the remote server, we would go to Are You a Boy or a Girl, get the remote server, and then instead of piping it into the local binary, we just pipe it into netcat. And alright, this challenge is annoying me, but you get the idea of what would happen. Normally there's something going on there. Cool. The other challenge was search engine with 0 solves. Search engine was a little bit more tricky, just because this required you to do, oops, damn it. Oh, I'm going wonderfully today, aren't I? MonSec. Being a CTF. This is binary search engine challenge. Clear that out. Let's get rid of you and start you again. Yeah, so if we actually run search engine, we get this. It's a fake search engine, obviously, if we want to search something. It repeatedly asks us, did you mean shellcode? Did you mean shellcode? Did you mean shellcode? That was a hint that, hey, maybe we need to use something called shellcode. What is shellcode? Well, shellcode is basically just, you remember earlier how we overwrit the return address with hexadecimal values to control code flow? Well, that code flow was in, basically that pointed to another part of memory, which, doing that, that pointed to another part of memory, which was, again, all hexadecimal values. Yeah. Whilst it prints out here as push, move, stuff like that, at the end of the day, what the computer sees, all this is hexadecimal. So what shellcode is it is basically just a bunch of shellcode which does very specific things. If you want to look at some really good examples of shellcode, then Shellstorm is a nice resource for it. In particular, if you want to go to the x86 here and look at something like, there's a good one, the BNSH. Yeah, that's sort of what it looks like. This string part is all you really need. The rest of it's pretty much just authors and what's going on. So let's switch over to search engine, go to challenge, and then make an exploit. Okay, same thing again. Make sure to do it with Python 2. We'll need 3 things for this. We'll need the return address, we'll need the padding from earlier, so that's basically just buffer overflow stuff, and then we'll also use shellcode here. Cool. And then padding and return address. So this is pretty similar to what was happening previously. So we know how to do this, don't we? Cyclic 200. Oh. Run it. Crash it. Get the address. Cyclic. Find the address. 140. Boom. There we go. What return address do we want? We'll come back to that later. What shellcode do we want? Well, what about this one? This will spawn a bash shell, right? So, let's paste that in. Let's format it correctly, because shellcode's always annoying to try and format. Oh, missed shellcode. And then, what return address do we want? Well, where is the shellcode going to go? The shellcode is going to end up on the stack, so we need the return pointer of the stack, right? That would be sometimes as easy as just getting the stack pointer at the point you want it. Say that one. Copy that in. testx10/xcd/ff/xff/xff. Yeah. So what if we did that? Well, Python 2, not 3, exploit. Put that into payload, and then we run it with payload. Sometimes that would work, but as you can see, equals to segfault in this case. The reason for that was that if we actually have a look at what ESP is, it's a different value. It changes every time the code runs, right? So we need something a little more general. We need maybe some sort of predictable instruction that would always jump to the stack. Enter gadgets. Gadgets were kind of hinted at or shown off a little bit in Deadrop, but basically what gadgets are is, if we look at, again, main, imagine we wanted a gadget to basically just to jump somewhere and then return, right? Oh, that's a bad example. Let's do, that's the last challenge. What is this? Vulnerable. That's right. Come on. No, it's searching this one. I'm a genius. Yeah, say we wanted to pop something and then return, right? Instead of writing shellcode, which could be anywhere in memory, why don't we use the functions that are already in memory? So why don't we, instead of jumping to the beginning of the function up here, return just to here? Alright? So that's basically what a gadget is. So how do we then, what sort of gadget are we looking for to jump to the stack? As I said earlier, the stack pointer, which is where the stack is stored in the ESP. So what if we just do wropper input the file of challenge, and then we put in, we search for jump ESP. And we do this properly. There we go. We find that there is one gadget that would do exactly that for us. So we take that address, we put it in here, and then we input it. So 8291.004.08. Just double check my working out. 9104. Yep. And we put that in there. Then we do -2 exploit. Put that into the payload. And then we run that. One moment. Cool. What have I done wrong here? We've got them. Actually, let's do this. Search. Let's actually break at the point to see exactly what's going on. So we run payload. We've broken at the return address. We can see that the return address we want to go to is this address here, which is exactly where the ROP was over here. So we jump again, we jump to ESP, and then we start executing the shellcode here. Okay, so maybe instead of us doing anything wrong, it's just bad shellcode, right? Which is something that is uncomfortably common in binary. So then what if we do, we'll just search shellcode bash. Let's try a different one then. So let's try this one, because we know the exploit is working since we did jump and then we're in the stack here. You can always tell that it's the stack because it'll generally be the very, very low memory, starting with FFFF, whereas the memory from earlier you'll see was in sort of the 0x80 range. Cool. So let's put this one in. And fight with the formatting. Oh, where is it? There we go. There we go. Pump that into a payload, put the payload back into here, stop at the return address, jump, jump, and then we can see this is now different because we've changed the shellcode. Continue, and it worked. We have executed a new program, that being bin bash, and then we have exited out of it, right? So let's now run that exact same payload on the challenge. Nope. And it didn't work. We're not actually in a shell. It basically just instantly exited. That's another issue with shellcode generally, is you'll find a lot of the time Bash doesn't like to work with shellcode just because what are called pipes are broken. Basically in Linux, this is a virtual terminal where all the data you're inputting is getting piped into the binary through something called standard in and standard out. When you do shellcode, it spawns the binary, yes, but it kind of doesn't hook up the pipes properly, and that's probably where a lot of you fell flat, and that's also where I fell flat, actually developing this challenge. But there is a very simple way around this. see, if we go digging a bit more, we will find this one here. This shellcode doesn't actually spawn bash as an interactive program. It actually tries to run some sort of command here. See? I think there was a better version of this on... shellcode bash cmd. That one. There's a better version of this one on exploitdb. By the way, if anyone is looking to do OSCP or anything like that, exploitdb is your lifeblood for being an actual penetration tester. Keep it bookmarked. Cool. So in this case, we can take this, and you'll see that it does exactly... actually, this is the command it'll do. So this one will actually pump out the etc password file, which was the exact same file that Mariesh's XXE attacked earlier. Now, because I'm running this on my own personal laptop without a VM, because I know security, I'm not actually going to do this. Instead, I am going to change it up a little bit. Pretty much all you need to do to change the command on this is to go to something like CyberChef, pump that in, again clean it up a bit, and then from hex you can see, that's exactly where the command is, right? So if we open up another CyberChef and we go, don't want you, 2 hex this time. Nope. There's 2 hex. There we go. And we do that, and we want instead to do maybe cat flag.txt. We can copy this and basically just override where cat is. Oh, let me select the delimiter so I can actually... What's happening? There we go. We can actually override it, and if you highlight it down here, CyberChef does this really awesome thing of highlighting it up this way. So we just replace that. We can see that now the command that would be run would be cat flag. We put that in as our shellcode, remembering to make it a string in Python, pump that into payload, and now if we do that into challenge, we get the flag. In this case, it's in my development environment, so it's debug, but if we go to the actual challenge, oh, that was the exact one I wanted, and we took the remote address, we could very much do cat payload into here, and yes, this one actually works. There you go. So that's pretty much how you get into shellcode and doing your own arbitrary code instead of relying on the code of the binary itself. And that's pretty much all I've got to do for now. I will go check if there are any questions in the Twitch chat. Doesn't look to be any. Any on Discord? Or doesn't look to be any either. Alright. If you do have any, feel free to ask them, again, in Discord or on Twitch. I'd be happy to answer them. But for now, I think I will pass it over to, I think Salang is next with some crypto. Cool. Alright, I think I caught him off guard, so stick with me for a little bit. Let's actually go back to this one.
Okay, awesome. People can hear me. Can you please put down in the Twitch chat that you can hear me so that I know that you're there? There's like 8 people watching. 8 people. Yay! Amazing. Here we go. um, let's see. What should we start off with? Um, well, how do I know who's actually in this chat besides the community members? If there's anybody in the Twitch stream that is not part of the community member, do you mind just like messaging us, being like, "Hey, I'm still here" or something, so we just know that you're still there. It's not only us. Awesome. I don't know how much of a delay this has, but let's just see. All right, well, let's just start off with the most basic one, I guess. Let's start off with quickly first space. Um, it's quick. It's just a description of base. So Cyber Chef. Shout out to Mario for showing me this. Uh, that's fine. I'll just go through them because why not? Go through all of them. Let's go from basic to 4. Hey, look, I found a flag. I think everyone's got this. 12 solves. Just gonna submit it because I haven't done it. So. um. All right. Besides that, Julius pitches the curve ball. This is Caesar Cypher. Go through this really quickly. It's just showing how to do this, really. I don't think this is the right one. I think this would be the right one. Actually, I'll just get a new one. Caesar Cypher Solver. Okay, here we go. And we've got this stupid thing. We're just decoding. Easy. Yeah, that's the wrong one. Good one. Got that. Got that. Now, we're not too sure exactly what it is, so we can just go through all of them. Amazing. I love tools. Okay. Here we go. Where is it? Maybe it's the other way around. I think I missed it. Oh, hey, look. Flag, get wrecked scrub. Just gonna chuck it in because why not? Got it. Here we go. So Julius pitches a curveball. You hit a home run and yell to Julius, get wrecked scrub. Amazing. Who liked the challenge? I personally did because I made it. Yeah, that's right. Can't do much, hey? Um, let's move on. A French guy's heart-touching speech. There's one less solve on this. And I believe I completely forgot what it was, so I'm just gonna Google it really quickly. Engineer cipher, decoder. I think it was this one from my memory. Ah, maybe not. I think it was this one. Yeah, yeah, this one was it. So, man, completely forgetting everything right now. Wow. Automatic decryption. Hey, look, I have found the key. And it's meant to be. Oh, crap. Um, so I have gotten a motivational paragraph for you guys to read once you've done the challenge. So hopefully you've actually read it and been inspired by it. Just saying. For those who wants to read it, let's chuck it here for a bit. Probably read it. Great. Submit it. Awesome. Now, let's go to the hard stuff now. Got 9 people in here. That's awesome. Awesome. We need more people. Surely, Discord, someone please. Someone please. Join us. I'm just gonna add everybody in the Discord channel. Being like, at everyone. Join MonSec Twitch chat if you need help with crypto challenges. Sure. And I'm gonna put join MonSec slash live twitch.tv slash Monash Cybersec. That's right. Anyways, let's just move on with this. Let's look at that. Turning up to Bletchley Park. I think I have around 20 minutes to present this, so it should be alright. I did pull it up, so I did bring up an Enigma machine. So I believe this is all we've really needed. Essentially, the reason why how I got that machine is going, hey, turning up to Bletchley Park. I wonder what that Bletchley is. Bletchley Park. Oh, okay. Hey, that's pretty cool. That looks like some code breaking. Wikipedia. Amazing. Bletchley Park. Who knows this place? It's in the UK. Yep, UK. Amazing. I can see it right here. So we have a Enigma machine, German Enigma, and Lawrence ciphers. So if you ever see anything related to Bletchley Park, then probably Enigma or Lawrence. And one of the famous Alan Turing guy, forgot what he was. He made the Turing machine. Amazing lad. Give him a shout out right now. Awesome. Oh man, we've decreased to 7. So sad. But let's move on. Bletchley Park. So that's how I got that. And with the Enigma machine, we were given these cogs essentially, rotors. That's what they call it. Let's copy that first. Chuck it in. Decode. Chuck that in. Awesome. We've got Enigma M3 UKB. Yep. Motor 6. Position was 17. 17. Ring. What's ring? Let's sign. No, that's K. K was 11, I think. Yep. K is 11. J is 10. And 17. 1. Yep. 12. D. This is 3. Oh, 4. My bad. Because we got 12D. Yeah, my bad. That's the wrong one. Someone please help. There we go. So we got rotor 1, rotor 3, rotor 7, 6. Can't really count. 3, 1. Amazing. I think we've got it, to be honest. Let's just copy and paste. Looks about right to me. Just chuck it in and go flag. Chuck that in. I've already solved this. But, hey, it would have told me that I haven't solved it. So, thing, flag. Oh. The flag is Alan hacked the Germans. and we've got the flag. I'm pretty much showing you how to do the whole thing, so bear with me. 8 people here. So now let's go to the harder ones. We got jigsaws. So first thing, we have an equal sign here. That equal sign right here pretty much tells us that it's a base 64. So hence we must copy. Yep, copy. Excuse me. Excuse me. Copy. Okay, awesome. Let's copy that. Let's decrypt it to where it's base 64. That's the wrong one. Base from base 64. So paste that, and we have gotten this. Firstly, now we have the XOR. We have XOR brute force, and the length of this is 148. 148. So we chuck in the length. We bake, and we know the flag there's a known text of flag in there, so we have flag that. Let's copy and paste. Hey, looks like we've already solved it. Johnny's cat. So this one, it requires hashcat and John the Ripper. So if you haven't never really used a tool, you can just Google John the Ripper. You can use John the Ripper to crack the password here, or you can do hashcat, which I can't really do that right now because I don't have Linux. So basically, 5 decrypt. So the decryption of this was simply to decrypt this secure password. I have found a hash. That must be the flag. Correct. So essentially what I did was kind of cheating, but because I didn't have the necessary tools, so I just kind of guessed it. Not really guessed it, jokes. So what you're meant to do is I'm going to use John the Ripper to figure out the type of encryption used, and then we just decode that, or we can use hashcat, which is another recovery tool. So we have the file here, and we can use hashcat to solve that. Sounds good to me, honestly. Not too bad. Not too bad. Now let's go to the bad ASCII. Well, firstly, shout out to Mario for doing this one. I absolutely loved it. I just gotta remember how to do it, to be honest, because I completely forgot. But hey, let's figure it out together. Firstly, chuck that in, and let's go. How long is that? 1300 length. So let's remove that. So firstly, it looks like it has been so we know it's a bad ASCII, a simple SOR. So we have a simple SOR thing. So essentially, I believe what I'm meant to do is SOR this first with a sample length of 1300 from my memory. And we know the flag, there is a crib called flag. And if I can just find that. Awesome, so we got nothing. Now, hey, look at that end. I wonder what this is. I wonder what I can do. Usually, just by looking at it, if you're able to check, there's a lot of uppercase and lowercases in here, and a lot of numbers. So if we have a lot of uppercase and lowercases, so we got a lot of uppercase and lowercases. So Marish just mentioned that we're meant to use some tool. And there's a lot of alphabets and uppercase, lowercase, and numbers like this. It's good to just go, hey, base 64. Who's up for that? Oh, can't type. From base 64. Let's chuck that in. Hey, look. I've got something. I've got something different. So firstly, let's look at that. BA. Hey, look, it's Japanese writing. But I think, where's the flag? Where is the flag? Oh, look, that looks kind of similar, but that doesn't look right, eh? Doesn't look right to me. Let's move on. Next key, we have BA with some Japanese writing. Just a bit of a hint there. Mario did some Japanese, hence he's made the flag, which means that looks like we'll get the flag. Thanks, Mariusz. And if you don't know the reference to this is a song. So quickly, I'm gonna play the song in the background so that you guys can listen to it while I'm doing the challenges. Hey guys, we're back into it. So we've got this flag, and we've got two solves. Well, that doesn't include me. So we've got flag of black and white. Oh, right, my bad. Yes, I can't play this apparently. I am not able to play that. Let me just close that quickly because I have apparently breached copyright if I do that. But play the whole thing. I played the early part, so hopefully I don't get sued for it. But otherwise, we have the flag called black and white. Awesome. Yeah, I just got told off. Just got told off. I love being told off, guys. It's great. Now I'm actually unable to do this because I actually have no idea. But we could skip this one. And for people that is really wondering how to do this unhygienic, here we go. I solved this today, so please don't no judging about how I solved this, but this is how I solved it. So watch me solve it again. Firstly, we know unhygienic is a one-time pad. We are given one-time pad. Frank is to not how you choose his password, but including with on one-time pad which is unbreakable. However, he had poor crypto hygiene and reused the same key. So the flag is the key. Most of the plain text is uppercase. Yes. So here, essentially, we are able to Google some of the things. Let me just close all that because we've already gone through all of them, didn't we? Awesome. If we're able to Google one-time pad, we have one-time pad. So how bad is it? Essentially, it's not meant to be cracked. Cannot be cracked. But there's a special case where we have. I have Googled this a while ago. To cipher double encryption. With two randomly chosen keys. That's the wrong one. Take advantage of one-time pad key reuse. Okay, so now we have given this thing. There's a graphical representation of it. When we have one pad, that's cool. That's all cool. It's amazing. There's an encryption of depth. But when we have two, if you've used it 2 times, the key is 2 times, and we are able to crack it. So that's amazing. Other than that, how did I actually find this? I just did one-time pad. I googled some stuff. Let me just look at my history and check what I did, because I'm kind of lost as well. Right, that's what I did. Go OTP cracker. Oh. Hey, OTP key reuse vulnerability cracker. Oh, I wonder what this is. Hey, look, it has given us a lot of details. If you can use this if you want to, but I'm gonna show you how I've done it, which is through a special tool called OTP cracker. This tool here. So we have firstly have a crib drag calculator, which is required when we are cracking out reused OTP. So essentially, first we have the ciphertext, which is the first one. Let me just copy that. First ciphertext, chuck that in here. Second one, chuck that in there. Awesome. And now, first thing we gotta do is guess. I love guessing. Can someone in the chat please guess a word what will be in here? Just a side note, the person who made this challenge was Mariusz, so we're just analyzing Mariusz right now. So, I wonder what Mariusz would think in this situation. He's Japanese in this one. I wonder what he'll use in this one. Probably English, eh? Most likely English. Let's look for some hints firstly. Hint, flag as a key. Hint, most of the plain text is uppercase. It's quite big, honestly. It's quite huge. And Uppercase. Whoa. I wonder what will be quite common when we're doing flag. I like that. Flag. Flag. Let's look for flag. Uh, anything that looks like English to you here? Out of the green, doesn't look like there's nothing here that is being used. Nothing green. How about what are some other words that Marius already used in this here that we can use? Yep. So let's look at this. Hmm. Let's look. Maybe hygiene. This is what my initial thought was actually, going hygiene, because maybe he would have used the same one again. Scrolling down, nothing in the green. Greens are the one that might be most likely possible that it would have been the word that we're looking for, but it doesn't look like it is. So I'm just gonna give you a small hint that it's obviously something that really stood out was just putting password in. I literally kind of brute forced it, looking into each one of them, things like putting in one-time pad, unbreakable, and key, reused, uppercase, or anything that, or friend, even friend. I've tried that, didn't come up with anything. So I put in password, and password actually gave me something here. So password, hey, what is this? Tell. I've got tell here, interestingly, and looking down, and I got this. This looks like a word to me. We got two. So to use this tool, we just press on this output one, and it gives us that there's an output here on the left side. So essentially, we have kind of guessed what the message might have been. Now let's look at the next one. We have RD and to goo. Okay, we'll chuck that in. It's kind of unusual to have password twice in a file, in my opinion. We can try putting it into the left side first, and later get it, but I don't think that that message would have two passwords in the same file. So it was kind of a guess that I just did, that the password would have been on one file and the other, because Marius would probably do that. So okay, let's go. We got a password here and we got something here. And next, let's look. What is this? I don't need that. Let's close that. Maybe passwords might be in the word, in the message. And let's look. Hey, looks like we've gotten somewhere with the extra stuff. Hey, that is quite useful. Let's put that in. Output 1, output 2. Awesome. Passwords, tell, and is there anything that we can do? Maybe spaces, because usually words have spaces, so maybe spaces will help on each side of it. Okay, let's see. Oh, we've got something else. Looks like that kind of looks similar to something that we've done on output 1, output 2. Passwords, tell any, are to guess. That looks like guess to me, so I'm gonna go to guess and space to include the next one. And we've got this swords in, because looks like it's this section here. So output 1, swords in. That's big clue. To guess. It looks like harder to guess, doesn't it? And we'll put a space in the side because that kind of helps with the next one. Oh, that's the wrong one. Please don't. Hopefully I didn't click that. Output 1. Are passwords hard to guess? We are guessing, essentially. So right here, I thought, obviously it's a password, so maybe we shouldn't tell anyone. But shouldn't doesn't really go in this. So looking at it, I go, maybe don't tell anyone our password or something related to that, but it's not. So look here, I went, do not tell any we have make password. Maybe that's not right. Any. Do not tell anyone. Anyone? Anyone? Oh, yep. Do not tell anyone. We've got this from the left side. Output 2. Awesome. Do not tell anyone. We've gotten somewhere with that. Verse. Very hard. That kind of looks very. Let's look. Very. Where would that go? Looks like it will go here. Very. Okay. Awesome. That's just a forward. And just thinking about, just trying things. I just did double very here. Very, very hard. That looks kind of, which looks kind of, it does make sense to have very, very hard. And we've got this one I store pa. Don't tell anyone I store passwords in. I've gotten somewhere with that. In, space that, passwords in. Type that in here. Passwords in space. And we have gotten guess B, output 2, B. Oh, we're so close. Only the last section is to guess, make passwords very, very hard, but guess, to guess, but because, nothing's green. I don't think that's right though. Most likely, yep. Now we have but. We're gonna try but, and we've gotten something here. Output 2. Oh, done something wrong. Apple 1, my bad. To guess, but. And now we got in plain place. I started thinking of place, but I don't think it was. And look, and this is where I got this word, plain text. Plain text. Okay, plain text. Do not tell anyone in plain text and space, which got us that, but easy to space, easy to plain text O. What did I do here? It was really confusing in this situation. I was stuck on this. I was stuck on this for like an hour to figure how to do this from this section. Yep, that's good. Duck here is really helping me out right now in the chat alone, but he's good. Always good. Thanks for supporting us. Always appreciate it. And now what we do is we try to figure out what the last word is, which is quite hard, and I thought. Yep, so now we are able to just go. I started brute forcing in here, to be honest. I said it or. Go, anyone, don't tell anyone I store password in plain text or. Okay. So it's good to put this rest in here as well. Or. This doesn't look right. Maybe or to the space. NE. I'll chuck that in. Easy. No, that's the wrong one. My bad. In here. Or to. This is where I was really stuck, but easy to remember. Oh, actually. Easy to. You've done this, haven't you? Damn you, bro. You got it right. But easy to remember. So how I got this was that I went plain text on space, and that's where I got this easy to read as I was looking at it, but easy to remember. Oh, bro, that's tough. Remember. And now we've got this section, which is plain text on my desktop. And that's the second section. Remember, exclamation mark. And I was done, and I was so happy about this one, but I didn't know what the key was. It's annoying. I got the text. Awesome. Great work. Great was along, but you haven't got the key. What do I do now? Let's look. So I started googling more, googling more, and I've gotten that it is we are able to do some SOAR. What was the site again? Crap. Completely forgot what the site was. However, if we're able to store both of them, then store the ciphertext with the message, then we are able to get the key. Hence, we can use this bad boy right here. We have SOAR, and first thing we can do, yep. So we can SOAR. Essentially, we are able to get one of them, chuck it in. Let's go. That one. Cancel. I love my buttons. SOAR with key of being my. Hey, what happened here? Give me that again. Awesome. Do not tell anyone I store password on this. So key and hexa from CTF 8. Didn't get anything. Yeah, this is where I was stuck as well, honestly. I got stuck here and I started asking if you store the message with the ciphertext, you get the key. Yep, that's what I'm doing. And I haven't gotten anywhere with this right now, so what to do? It's a hex right here. So why not go from hex to that? Hey, look. We've gotten something here. Now we've got the flag. I believe and we've submitted it. We've got a solve. And I should be looking, if you're able to view this again, then hopefully we have more solves, honestly, because I found this really interesting with this section, because it took me ages, but I eventually got it, so I was really glad that I got it. But now, bad ASCII, it's pretty good. Other than that, I think that's all about the crypto section. So, well, firstly, thank you all for just joining us, and make sure to check out our Discord if you haven't yet, which should be, if you're able to ask on Facebook, being like at Facebook, ask where the Discord link is, and we are able to help us out. And we would really appreciate you to do the attendance and the survey for the CTF, because thanks Duck for participating, and it was great to be able to host something pretty good online. So we have MonSec chat is Discord, so let me just copy this link, chuck it in here to the chat if I'm able to put this here. Oh no, that's not what I want. Give me a second. Copy link address. I love this. go.monsec.io/chat for Discord. And and that's about it. If you're able to do the attendance or the survey, that'll be amazing. And I think that's about it. And I'm gonna probably wrap up around here. Thank you all for coming, and see you all soon.